Hello and welcome to this tech tip from Will. In the last video, I showed you how to create a Generation 1 virtual machine in Hyper-V for Windows 10. In this video, I'll look at the settings for a Generation 1 virtual machine. Understanding the settings that are available to you will help you make the right choices when configuring Generation 1 virtual machines. So I'll now change over to my Windows 10 professional computer with Hyper-V installed to look at the settings for a Generation 1 virtual machine. From the desktop of my Windows 10 computer, I'll first open HyperV Manager from the Start menu. Once in the HyperV Manager, notice under the Virtual Machines heading that we have a virtual machine named VM1. This is the Generation 1 virtual machine that I created in the last video. To configure a virtual machine in Hyper-V, simply right-click on the virtual machine and select Settings. This will open the Settings dialog for the virtual machine. As you can see, there are rather a lot of settings here, far too many for me to cover all at once in any real detail in one video. In this video, I will simply give you an overview of the available settings so that you have a good understanding of what can be achieved with your virtual machines. In later videos, I'll look at the individual settings in more detail. The virtual machine settings are easily split into two types: hardware and management. The hardware settings allow the administrator to configure the emulated hardware for the virtual machine in much the same way as physical hardware found in a regular computer would be configured. Meanwhile, the management settings will focus on the behavior of the virtual machine. To begin with, I'll look at the hardware settings. The first setting is the Add Hardware setting. This setting allows the administrator to add more emulated hardware to the virtual machine. When emulated hardware is added to a virtual machine, that hardware will appear listed in the Hardware section. Hyper-V for Windows 10 allows 5 types of hardware to be added. The first hardware type is a SCSI controller. SCSI controllers allow the administrator to add more storage to the virtual machine. That is, once a SCSI controller has been added, the administrator can then attach up to 64 virtual hard disks to the SCSI controller. If you're creating virtual machines that will require a lot of virtual hard disks, you may have no choice but to add a SCSI controller. Generation 1 virtual machines in Hyper-V support up to 4 SCSI controllers per virtual machine. The second hardware type is a network adapter. If the virtual machine will be joined to a network, it will, just like a physical computer, require a network adapter. Once the network adapter has been added, the virtual machine can then be configured for network connectivity. In a later video, I will look at networking Hyper-V in a lot more detail. Generation 1 virtual machines support up to 8 of these network adapters per virtual machine. In most cases, this should be more than enough to meet your networking requirements. The next type of hardware is the Remote FX 3D video adapter. The Remote FX 3D video adapter is designed to provide better graphics for your virtual machine. When the administrator adds the Remote FX 3D video adapter, a WDDM driver is installed onto the virtual machine. After installing this driver, the virtual machine is able to access the graphics card on the Windows 10 Hyper-V computer directly. This allows the virtual machine to provide a richer graphical experience, such as 3D graphics. It's worth noting at this point that virtual machines with a Remote FX 3D video adapter have to be administered using a remote desktop connection. You cannot administer them locally in Hyper-V Manager. Also, only one Remote FX 3D video adapter can be added to each virtual machine. Next, we have the Legacy Network Adapter. Legacy network adapters are only available in Generation 1 virtual machines. The difference between the Legacy Network Adapter and the network adapter we covered earlier is that the Legacy Network Adapter supports PXE booting. That is, if the administrator plans to install an operating system onto a Generation 1 virtual machine over the network, the administrator must first attach a Legacy Network Adapter to the virtual machine. In other words, legacy network adapters allow Generation 1 virtual machines to boot from the network and install an operating system. You cannot install an operating system onto a Generation 1 virtual machine over a network using the regular network adapter. Generation 1 virtual machines support a total of 4 legacy network adapters, which, for the majority of cases, should be plenty. Lastly, we have the fiber channel adapter. With the fiber channel adapter, the administrator can connect a HyperV virtual machine directly to a fiber channel storage array. To do this, the administrator must mount the fiber channel adapter listed here to a physical fiber channel host bus adapter installed in the Windows 10 HyperV computer. Furthermore, at the time this video was recorded, virtual fiber channel can only be used with virtual machines that are running either Windows Server 2008, Windows Server 2008 R2, Windows Server 2012, or Windows Server 2012 R2. Generation 1 virtual machines support a total of 4 virtual fiber channel adapters per virtual machine. The next setting I will look at is the BIOS setting. The BIOS setting allows the administrator to adjust the boot order for the virtual machine. Just like with physical computers, if the administrator wishes to change the boot order, these changes have to be made in the computer's BIOS. Generation 1 virtual machines support booting from a virtual CD drive, virtual IDE controller, legacy network adapter, and from a virtual floppy drive. When a Generation 1 virtual machine is powered on, the virtual machine will search for some kind of operating system. The startup order listed here is essentially where the virtual machine will conduct its search, starting from the top of the list and working down to the bottom. Using the Move Up and the Move Down buttons, the administrator is able to adjust the startup order as required. The next setting to discuss is the memory setting. This setting allows the administrator to decide how much RAM is taken from the Windows 10 HyperV computer and is given to the virtual machine. The first parameter, RAM, shows the amount of RAM in megabytes that will be allocated to this virtual machine. In my case, this is set to 4096 megabytes, which is precisely 4 gigabytes. If I were to make no further changes on this page, the virtual machine will receive 4 gigabytes of RAM when it starts up, and the virtual machine will not give this RAM up. However, if I were to tick the checkbox Enable Dynamic Memory, this will allow the administrator to fine-tune the RAM memory settings. Dynamic memory allows the administrator to choose the minimum and maximum amount of RAM memory the virtual machine will receive. Dynamic memory works by allocating only the amount of RAM required by the virtual machine at that specific point in time. That is, when the virtual machine is idle, it will only receive a small amount of RAM. However, during busy periods, the virtual machine will receive more RAM for the duration of the busy spell. The point of dynamic memory is to save RAM by allocating only what the virtual machine requires. In a later video, I will cover dynamic memory in more detail. For now, though, I will leave dynamic memory disabled. Next, we have the processor setting. Here, the administrator is able to configure the amount of processor power the virtual machine receives. The main setting on this page is the number of virtual processors. When a virtual machine is first created, the virtual machine is assigned just one virtual processor. A virtual processor is essentially one processor core. Before creating a virtual machine, it's worth taking the time to add up the number of processor cores you have in your Windows 10 HyperV computer. In my case, I already know that this Windows 10 computer has a processor with 4 cores. I therefore have a total of 4 virtual processors that can be allocated to virtual machines. Using the up and down arrows, the administrator can adjust the number of virtual processors assigned to the virtual machine. Below this, we have the resource control parameters. These parameters allow the administrator to fine-tune the amount of processor power the virtual machine receives. In a later video, I will cover these settings in more detail, so don't worry too much about them just yet. For now, all you need to know is that virtual machines use virtual processors and that one virtual processor is equal to one processor core. The next two settings are the IDE controllers. IDE controllers are only found in Generation 1 virtual machines. When you create a Generation 1 virtual machine, you're automatically given two virtual IDE controllers, IDE Controller 0 and IDE Controller 1. You cannot remove IDE controllers from a Generation 1 virtual machine, nor can you add additional IDE controllers. IDE controllers allow the administrator to connect drives to the virtual machine. These drives include both hard drives and DVD drives. The option Hard Drive allows the administrator to connect a virtual hard disk to the IDE controller. Alternatively, the administrator could also choose to connect a physical hard disk from the Windows 10 HyperV computer directly to the virtual machine's IDE controller. Physical hard disks that are connected directly to a HyperV virtual machine are known as pass-through disks. The other option, DVD drive, allows the administrator to mount a physical DVD drive from the Windows 10 HyperV computer directly to the virtual machine's IDE controller. Once this is done, when a CD or DVD is inserted into the physical DVD drive, the optical media can then be read by the virtual machine. Alternatively, the administrator could also mount an ISO file to the IDE controller. Just like with IDE controllers in a physical computer, the administrator can connect up to two drives to each IDE controller. One point I'd like to make, however, is that the hard drive that contains the operating system for the Generation 1 virtual machine must be connected to an IDE controller. If the operating system drive is not connected to an IDE controller, the operating system will not boot. In a later video, I will cover virtual hard disks, pass-through disks, and how to connect them to an IDE controller. So don't worry about this just yet. For now, all you need to know is that IDE controllers connect drives to the virtual machine, and that the operating system drive for a Generation 1 virtual machine must be connected to an IDE controller. The next setting I will look at is the SCSI controller. SCSI controllers essentially perform the same job as IDE controllers. That is, SCSI controllers are yet another way to connect drives to the virtual machine. However, there are some differences. Firstly, and most importantly, SCSI controllers in a Generation 1 virtual machine cannot boot an operating system. If an operating system drive is connected to a SCSI controller, the operating system will not boot. Operating system drives should instead be attached to IDE controllers. Furthermore, SCSI controllers in Generation 1 virtual machines do not support optical drives. In other words, you cannot use virtual DVD drives with a SCSI controller. SCSI controllers allow the administrator to simply add data drives to the virtual machine and nothing else. If you select the option Hard Drive, this allows the administrator to add either a virtual hard disk or a physical pass-through disk to the SCSI controller. The next option, Shared Drive, allows the administrator to add a virtual hard disk that is shared. A shared drive is essentially a virtual hard disk that is attached to multiple virtual machines at the same time. Shared virtual hard disks are most commonly used for clustering. In later videos, I'll look at shared virtual hard disks, so don't worry too much about this yet. The next setting, Network Adapter, is required to connect the virtual machine to some kind of network. If the virtual machine will be standalone, in other words, it will not be connected to any network whatsoever, you have no need for a network adapter. However, in the majority of cases, the administrator would likely want to join their virtual machines to some kind of network. Networking in HyperV works by creating what is called a virtual switch. Once the virtual switch has been created, the administrator can attach the virtual switch to the virtual network adapter. At the top of this screen, notice there's a pull-down option, Virtual Switch. Here, the administrator can choose which virtual switch this network adapter will connect to. As you can see, the only option I have at the moment is Not Connected. This is because I've not yet created a virtual switch. Further down, we have the option Enable Virtual LAN Identification. Virtual machines in HyperV are fully VLAN compatible. Once this checkbox is ticked, the administrator is able to specify which virtual LAN the virtual machine will be connected to. The option below this, Enable Bandwidth Management, allows the administrator to cap the amount of bandwidth the virtual machine can use. This is achieved by entering the minimum and maximum amount of bandwidth permitted. In later videos, I will cover virtual switches and virtual machine networking in a lot more detail. The next two settings are the COM ports. Generation 1 virtual machines come with two COM ports, COM1 and COM2. COM ports allow the administrator to connect a HyperV virtual machine to a serial port on the physical Windows 10 computer. This is particularly useful if you wish to connect your virtual machine to some kind of legacy hardware device, like a printer, for example. It is not possible to add additional COM ports, nor can the administrator remove a COM port from a Generation 1 virtual machine. Since serial ports are extremely dated technology, COM ports in HyperV are very rarely used. The final hardware setting is the Diskette Drive. The virtual diskette, or floppy drive, is only available in Generation 1 virtual machines. Once configured, the Diskette Drive gives the impression that a floppy disk has been inserted into the virtual machine. This allows the administrator to move data in and out of the virtual machine, albeit in small amounts. To use a virtual diskette drive, the administrator is required to create a special type of file called a VFD, or Virtual Floppy Disk File. Once the VFD file has been created, the administrator can use the Browse button to attach the VFD file to the virtual diskette drive. Once the VFD has been attached, this will give the impression that a floppy disk has been inserted into the virtual machine. Just like with traditional floppy disks, you are able to save up to 1.4 megabytes of data to a single VFD file. The VFD file can then be removed from one virtual machine and then mounted to another virtual machine at any time. Well, that covers the hardware settings for a Generation 1 virtual machine. The next settings I will look at are the management settings. The first setting is a simple one, Name. This setting simply allows the administrator to choose a name for the virtual machine. Further down on this page, the administrator can also record notes concerning this virtual machine. Information recorded here could include, for example, the operating system version, the applications installed, and networking information. The next setting is Integration Services. Integration services will be covered in a lot more detail in future videos. For now, though, simply think of integration services as an add-on package for your virtual machines. Integration services, in a nutshell, are essentially a collection of drivers and services that can be optionally installed onto a HyperV virtual machine. When integration services are installed, virtual machines are generally easier to manage and will communicate better with your Windows 10 HyperV computer. After installing integration services onto a virtual machine, this is where the administrator can enable and disable the individual services. As you can see on this page, there are a total of 6 integration services. Don't worry about what the individual services do at this point. To enable a particular service, simply tick the relevant checkbox. On the other hand, if you wish to disable a particular service, simply untick the checkbox. Next, we have checkpoints. A checkpoint is essentially a snapshot of a virtual machine at a specific point in time. Checkpoints are used to save what is called the virtual machine state. The virtual machine state includes the contents of the virtual hard disk and the virtual machine configuration settings. By creating checkpoints, the administrator is able to return the virtual machine to the way it was when the checkpoint was taken. To enable checkpoints on a virtual machine, simply tick the Enable Checkpoints checkbox. Windows 10 Hyper-V allows the administrator to choose between production checkpoints and standard checkpoints. Production checkpoints are essentially point-in-time images that are created using backup technology inside the virtual machine. Standard checkpoints, on the other hand, capture the virtual machine state using saved state technology. As such, standard checkpoints are intended more for testing environments rather than production environments. The last option worth mentioning on this screen is the checkpoint file location. This is essentially where Hyper-V stores the checkpoint data for the virtual machine. In a later video, checkpoints will be covered in more detail, so don't worry if checkpoints don't make sense just yet. The next setting is the Smart Paging file location. The Smart Paging file is typically used with virtual machines that have dynamic memory enabled. The Smart Paging file is required at times when you want to restart a virtual machine, but the Windows 10 Hyper-V computer doesn't have enough RAM memory to do so. To address the problem of RAM shortfalls, the Smart Paging file converts free hard disk space from the Windows 10 Hyper-V computer into RAM memory. In other words, the Smart Paging file essentially creates a paging file that a virtual machine can use to boot itself. Of course, using hard disk space rather than actual RAM memory to boot a virtual machine will incur a performance hit, so using the Smart Paging file is best avoided if possible. The only setting that can be configured on this page is where Hyper-V stores the Smart Paging file for this virtual machine. Next, we have the Automatic Start action. This setting simply allows the administrator to choose whether or not a virtual machine should start up when the Windows 10 Hyper-V computer starts up. As you can see, there are a number of options here. The first option, Nothing, essentially means that the virtual machine will remain powered off when the Windows 10 Hyper-V computer starts. When this option is selected, the administrator is required to start the virtual machine manually. The next option, Automatically Start if it was running when the service stopped, will start the virtual machine automatically only if the virtual machine was running at the time the Windows 10 Hyper-V computer was shut down. The last option, Always Start this virtual machine automatically, will ensure that the virtual machine always starts when the Windows 10 Hyper-V computer is started. Below these options, Hyper-V allows the administrator to configure a startup delay. If you have a lot of virtual machines on your Windows 10 Hyper-V computer that you want to start automatically after a reboot of the Hyper-V host, this option is very useful. Startup delay allows the administrator to stagger the startup of virtual machines so they don't all start at the same time. If multiple virtual machines attempt to start at exactly the same time on the same Hyper-V host, this will cause some performance problems which can result in slow boot times. By configuring a startup delay, you can ensure that one virtual machine starts up before attempting to start another. You could even set this so that your more critical virtual machines boot up first. The last setting I will look at is the Automatic Stop action. The Automatic Stop action determines what will happen to the virtual machine whenever the Windows 10 Hyper-V computer is shut down. The first option, Save the virtual machine state, will copy the contents of the virtual machine's RAM memory to the hard disk of the Windows 10 Hyper-V computer. When the Windows 10 computer comes back up, the virtual machine will resume where it left off. The next option, Turn off the virtual machine, will power the virtual machine off without cleanly shutting it down. This is essentially the same as pulling the power cord out of a physical computer. The last option is Shut down the guest operating system. This option will ensure that the operating system on the virtual machine is properly and cleanly shut down. Well, that covers all of the settings for a Generation 1 virtual machine. Quite a long video, and although I didn't go into too much detail on the individual settings, hopefully now you can at least see what can be achieved with Hyper-V. In the next video, I will look at the settings for a Generation 2 virtual machine. I hope this video has been helpful and informative. For more tech tips from Will, please see our YouTube page. Many thanks, and we'll see you on the next tech tip.